Good morning, students. Today we will study about statistics. First we consider the objectives of this topic. First we will introduce this chapter by the introduction. Mean deviation from the mean deviation from the median, variance and standard deviations, shortcut methods to find out the mean and standard deviation. Now we come for the introductory part. As we will study about this topic based on your knowledge of either the class in earlier classes. This includes the knowledge of your data representation, measures of central tendency, that is mean, median and mode. The formula which we know that to find out the mean of the continuous frequency distribution is summation of fi xi upon capital N, where capital N represents the summation of the frequencies. Now, median is a continuous frequency distribution is given by the formula L plus N upon 2 minus capital F upon small f into h, where L represents the lower limit of the median class, F the frequency of the median class, h it is the width of the median class, capital F represents the cumulative frequency of the class preceding the median class, and capital N represents the summation of the frequencies. Now we come for the topic mean deviation from the mean. Let us first understand what mean deviation is. Mean deviation is the mean of the absolute deviations of a set of observations taken from a definite central value, can be mean, can be median or anything else. The keyword to note in the above definition is absolute. Only the numerical value of the deviation is to be taken, ignoring the sign. Mean deviation from the mean can be found out for the raw data, that is unclassified. In this case, the mean deviation from the mean of a set of observations is given by the formula summation of xi minus x bar modulus upon the number of observations, that is the absolute deviation divided by the number of observations. Mean deviation from the mean for the grouped data can be defined as, in this case, the xi's are the midpoints of the classes with frequencies fi. Then the mean deviation from the mean is given by the formula summation of fi into xi minus x bar modulus upon the total number of frequencies, that is capital N. Now we come for the mean deviation from the median. The only difference here is the mean is replaced by median, and we calculate the process by the same thing. Mean deviation from the median for the raw data can be find out. In this case, the mean deviation from the median for a set of observation is given by the formula summation of xi minus median, right from I to n upon the number of observations. Mean deviation from the median for the grouped data can be given by the formula summation of fi into xi minus x bar median, xi minus median, and divided by the number of total frequencies. Now we come for the next part for the statistics, that is variance and standard deviation. The variance of a set of observations xi is the mean of the squares of the deviations from the mean of the observations. The variance is denoted by the variance in bracket x or the symbol sigma square. Basically, in this, the deviations are being positive by making it square. If you now look at the definition above, there are three parts to it. So, for a raw data or a set of n observations, first, deviations from the mean of the observations, which is represented by xi minus x bar, that is the deviation from the mean. The second part is the squares of the deviation, that is xi minus x bar total whole square, the square of the deviations. And the third, mean of the squares of the deviations from the mean, which is given by the formula summation of xi minus x bar whole square divided by the number of observations. Now we come for the definition standard deviation. Standard deviation is defined as the positive square root of variance, and it is represented by the symbol sigma. The value of the variance and the standard deviation for a grouped data is given by, variance can be given as summation of fi into xi minus x bar whole square upon capital N. Deviation, standard deviation is the square root of the variance, that is square root of fi into xi minus x bar whole square upon summation of the frequencies. Now we come for the algorithm to find out the mean of a grouped data. In order to reduce the calculations involved in finding out the values of the mean and variance of a grouped data, the following algorithms can be used to calculate the same. Algorithms to find out the mean of a grouped data. First, write down the frequency table with a column given in the class marks, that is the mid values of the class intervals. Second, choose a number capital A, that is assumed mean. Most probably it is taken as the middle value. And then find out the deviation xi minus a, that is the deviation about assumed mean. And then we find out ui, that is deviation divided by the width of the class interval. Then multiply the frequency fi with the corresponding ui to calculate the sum of fi into ui. And then we find out the summation of the frequencies, that is summation of fi, which is represented as capital N. And then using the formula we calculate the mean, that is a plus summation of fi into ui upon n into h, that is the width of the intervals. Similarly, we can also use a shortcut method to calculate the variance of the grouped data, that is sigma square. To do this, write down the frequency table with a column given in the class marks, that is the midpoints of the class intervals. Choose a number a, usually the middle value, almost middle value of all the asides taken as di deviations xi minus a about the assumed mean. Then multiply the frequencies corresponding to di to calculate fi into di. Then obtain the squares of the deviations di square. After that, multiply the frequencies to this di square and calculate the sum, that is summation of fi into di square. Then find the sum of all the frequencies, that is capital N, and then we use the formula to calculate the variance, that is summation of fi into di square upon capital N minus sigma fi di upon capital N whole square. That is the formula to calculate the variance of this distribution. Now this can be taken as with an example. We consider an example to calculate the variance of this data. Considering the number of students absent in a school was recorded every day for 147 days, and the data is represented in the following table given. Here in this column, the number of students absent is given. In the next column, the number of days they were absent, it is also given. Then we obtain the median, describe what information it conveys. Also find out the mean deviation from the median. So two calculations we have to find out, that is median and the mean deviation about median. Solution of this part, we first calculate the median and the mean deviation. As we already done the formula, first column it is the mid values are given xi's and fi's. We will calculate the cumulative frequencies. Then we will find out the deviation, that is xi minus the median which we have got, that is 12, and then with the corresponding frequencies we will multiply. Then we will get the sum of fi into xi minus median. Here we find out the capital N is 147, so n upon 2 is 73.5. The cumulative frequency just greater than n upon 2 is 140, and the value of x is 12. The value of the median here signifies that for about half the number of days, approximately 12 students were absent. So the mean deviation from the median we can calculate by the summation of fi into xi minus 12, that was the median, and divided by the total frequencies, that is 3214 upon 147, and we get the answer, that is mean deviation from the median. Now we take another example. The following Data represents the expenditure pattern of a student for the month of July. The student gets rupees 50 every day as a pocket money. The data given is here, the expenditure in a class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50, and their corresponding frequencies are also given. Then we have to calculate the mean and the standard deviation. So we start calculating the mean first. We'll take the class, find out the middle values xi, the corresponding frequencies we have written. We'll multiply to calculate fi into xi. We'll get the sum. That becomes 635, the summation of fi into xi. The sum of frequencies here it is 31. Then we apply the formula to calculate the mean, that is summation of fi xi upon capital N, and we get the value 635 upon 31, that is 20.48, which is the mean. Now we have to calculate the standard deviation using the method. So the xi values are given to us, frequencies are given to us. Then we will find out the ui, that is xi minus the a value which we have already assumed, that is xi minus 25 upon the class width, that is 10, and we get it as ui. Then after that, the next column we will multiply the corresponding frequencies with the ui. Then we will calculate the ui square. Then the corresponding frequencies will be multiplied with the ui squares. And then we apply the formula to calculate the variance, that is summation of fi into ui square divided by capital N minus sigma fi ui upon n whole square, and whole bracket is multiplied by h square. So we get the value 100 multiplied by 44 upon 31 minus in the bracket minus 14 upon 31 whole square, and this way we get the variance 121.45. And then if we calculate the square root of the given data, we get the standard deviation. Now we take one more example to find out, that is an absent-minded professor was computing certain experimental data to find out the mean and standard deviation of 100 observations. He found the mean to be 40 and standard deviation to be 51. His assistant later found that the professor has by mistake read an observation value as 61 instead of the correct value, that is 91. Find the correct mean and standard deviation of the following experimental data. So for that we need to find out the incorrect mean by the formula sigma xi upon n, and we calculate the summation of xi, which becomes 4000. Now we calculate the correct values of the summation xi. That's 4000. We will subtract the incorrect value and we'll add the correct value. So we get the correct mean by the formula summation xi upon capital N, and we get that is 40.3. In this way we can calculate the standard deviation, that is 5.1. Here that is the variance is 5.1 whole square, 26.01. Now first we will calculate the summation of xi square using the formula. 26.01 is equal to summation xi square of the number of observations minus the mean whole square. This way we calculate the summation of xi square. That becomes 1620601. Now the correct value can be find out by the formula summation of xi square is equals to the incorrect values of xi square minus the incorrect value and by adding the correct value. So we get the correct summation xi square is 167161, and then we apply the formula to get the correct variance, that is summation of xi square, which was correct, divided by the number of observations minus correct summation of xi upon 100 whole square. And by substituting the values in this way, we get the value of the correct standard deviation, which is the square root of 69.2, that is 8.32. So this way we have calculated all the values which we need to find out the correct standard deviation as well as the correct mean. Thank you, students.